Okay, we're going to solve this problem. We've got this 40 kilogram block A on top of a plane here, a 30-degree plane. So right here's this plane. There's no friction between block A and the plane. Then on top of this 40 kilogram block A, we have a 10 kilogram block B, and it's just sitting on top there. Block A is pulled up the incline with this 500 Newton force, and the problem is to determine the smallest allowable value of the coefficient of static friction between the blocks. So what does that mean? Well, so what we've got here is imagine this plane is like ice, so we're pulling up block A. Block B is just sitting on top of A. And so if there was no friction between A and B, B would just stay here, and as A gets pulled up, B would stay here and fall off the block A. But that doesn't happen. There's some friction here, and so the question is determine the smallest allowable value for the coefficient of static friction between the blocks. So that's what we're looking for, friction between those blocks. We're going to solve this problem in two steps. We'll first consider this as a combined body and just calculate the motion of this AB block. So there's a mass of 50 kilograms. There's this force, 500 newtons, going this way. There's going to be gravity acting down, and so it's a simple problem. Calculate the motion of this combined block. So that's the first. The other consideration here is to choose an easy coordinate system. We could choose, here's x and y, and you can see if we do this, we're going to have, because of this 30-degree angle, the motions in this direction, we're going to have motion in both x and y. And so why don't we choose a simpler coordinate system, which is along the direction here parallel to this force, and so along in that direction we'll have all our motion, and there's no motion perpendicular to that. So we're going to work in that coordinate system that goes like this. And so, well, I'll call this x prime and y prime. So I'll start writing down the components from x prime first. We've got the 500 newtons. In this direction, so that's the positive direction. And then acting against that, we have this component of gravity. And so acting on A, and so I'll write this MAG times the sine of 30 degrees. Now how do well, so why the sine of 30 degrees? Well, I always do it this way. If you consider that this angle, if we take the angle instead to be 0 degrees, you can see what would happen, that all the gravity would be acting perpendicular to the force, and so that factor would be 0. So sine of 0 would be 0. Now if it were at 90 degrees, it would be acting directly against it, and that would be 1. So that's how I choose sine instead of cosine. Okay, so we've got the mass of A, and we've got a similar term for the mass of B. Sine of 30 degrees. And then that's going to equal the total mass times the acceleration. And that's the x prime coordinate. The y prime coordinate, well, that's just 0. There's no well, let's see, I could write it down. Let me simplify it. We'll go back here a second. It's going to be something when we write the forces, but it's going to equal 0. There's no acceleration in this direction, so we don't need, this sums to 0. Okay, I'm going to solve for A here. A here. And so I'll substitute in values for MA and MB. And so what do we have here? We have that A equals 500 newtons minus the mass of A was 40 kilograms, so I've got a 40 kilograms G sine 30, and a minus a 10, so I've got a 30 kilograms G sine 30 degrees, and the whole thing is divided by this factor, MA plus MB, which is 50 kilograms. If we just look at block B, so this is to do the second part of that problem. Block B here looks like this, where we've got, and we're going to write down the forces on this. It's got a the gravitational force acting down. It's got a normal force acting up. Call that the N sub B, and it's got this friction force pulling it along. So that's what, if we just look at block B, that's how things would look. We can sum all the forces on there, and the resultant is just what it is. It's the mass of B times the acceleration, and we know the acceleration's at that 30-degree angle. Now the coefficient of static friction, mu, is defined this way. It's that force of friction divided by the normal force. So here's the friction force, the normal force. Take the ratio of those two, and we have the coefficient of static friction. So all we need to do is solve this equation. We'll write down, the sum of the forces on B is equal to MB times A. We'll solve this equation, calculate the values for the force of friction and the normal force, and we can calculate mu. Okay, so we can see that from this diagram, the MBG and NB are acting perpendicular, opposite one another, and so we've got this force of friction here. And so let's just consider this component first, and so that force of friction has got to equal MBA right here, but we just need the component along this direction, so we'll take the cosine of 30 degrees. So there's one equation. We can calculate the force of friction, and then to write down the other part of it, we've got the normal force like this. We're looking at the sine. Now we just need to put the numbers in and calculate the values. So we know A, we know MB, we know G. So let's do that. And then the solution to the problem, the question was the ratio of these two, so it's 599.5 newtons divided by 133.4 newtons, and that equals just about exactly 4.5. And there you've got it.